SwayamPrabha. Digital India. Educated India.
Hello everybody, welcome to my course Reactive Intermediates, Carbenes and Nitrenes. I am Dr. Rajarshi Samanta from Department of Chemistry, IIT Kharagpur. Before going into the detail of this course, I would like to introduce that what is these reactive intermediates. Now, if we see all organic transformations, or rather I should say most of the organic transformations are going via multiple steps. That means they do not proceed in a single step. Now, in these several steps are required to get the desired product from a organic reactions. During this multi-step reaction sequences, there are lot of short-lived species can be generated, which quickly convert into different products, side products, other intermediates, different reactants, etc. They are in general very short-lived species, highly reactive, and they are very seldom isolated. These are actually called that reactive intermediates. Now, why they are important? Because all these reactions are generating this particular short-lived highly reactive species. So, that is why it is very important to understand those reactive intermediates, how they are forming, what are their roles in the reactions, and how their structures are actually getting shaped, etc. Now, as they are very short lived, it is not easy to determine their structures, but there are several experimental and theoretical calculations are there that can predict or determine the structures and geometry of those particular reactive intermediates. Now, there are different reactive intermediates generated during the organic transformations. As per example, carbocations, carbanions, free radicals, then carbenes, nitrenes, arines, etc. So, among all these reactive intermediates in this particular course, we are actually interested in these two reactive intermediates, that is, one is carbene, another one is nitrenes. Now, question is that why we would like to learn them, what is their importance? If we see in various synthesis of drug molecules, bioactive natural products, pharmaceuticals or organic materials of importance are actually during their synthesis, they are actually taking help of these particular intermediates. That means, for the synthesis of such type of biologically important compounds, the reactions required there those reactive intermediates are forming. So, I will show you in the latter part of this course that how these reactive intermediates like carbenes and nitrenes are important in the transformations of various organic molecules and how they are taking part or how they are actually emphasizing that reaction that we will learn. Now, the thing is that in this particular course we will not discuss the Fischer or Strock carbenes. We will not discuss in this particular course. That means, these metallocarbenes we will not cover in this course. Now, what are the books that we will follow this for this particular course? Like the books are Advanced Organic Chemistry Part B by Professor F. A. Carey and R. J. Sandberg. Then next book is Organic Chemistry by Professor J. Clayden, N. Greaves and S. Warren. Next is Carbene Chemistry by Professor W. Kinsey. Finally, the Reactive Intermediates in Organic Chemistry by Professor Mayasankar Singh. So, these particular 4 books we will follow for this topic. Now, we will discuss about the carbenes. Carbenes were first postulated by Professor Edward Buchner. Carbenes first postulated by here I would like to mention that he is a German chemist and got Nobel Prize in 1907. However, Professor Edward Buchner first postulated these carbenes in 1903. Then in 1912, Professor Hermann Staudinger who also got Nobel Prize in chemistry in 1953, he also converted alkenes into cyclopropane with diazomethane. the help of diazomethane. That means that this carbenes was previously known and people have slowly developed this chemistry. Finally, this term carbene actually conceived by Professor Woodward Doering and Weinstein. Even though this species was known before, but the name of this carbene that actually conceived by Professor Woodward, Doering and Weinstein. Now, among all these, the parent carbene molecule is actually this one. This is the parent and simplest carbene. Its actual name is methylene, but now for all these substituted this type of species are actually called carbenes. Okay. Now, what are their characteristics? Their characteristics are, as I mentioned before, like all other reactive intermediates, their characteristics are: number 1, definitely they are in generally short lived. That means, lifetime of those species are very short. Definitely they are highly reactive. Okay. Next, the fundamental difference between this particular reactive intermediates with the other reactive intermediates are, here they are neutral. That means their formal charge is 0. They are, unlike other reactive intermediates, they are divalent in nature. Okay. They have 6 valence electrons. Okay. Among them, among these 6 valence electrons, they are actually having 2 covalent bonds that involves 4 electrons and two non-bonding electrons. Okay. So, these are in general their characteristics, like they are short lived, highly reactive, neutral, they are divalent in nature, they contain 6 valence electrons and they have 2 covalent bonds and 2 non-bonding electrons. That means, if you have this, they have these 2 covalent bonds and these 2 non-bonding electrons. That means, they are having these 2 covalent bonds and 2 non-bonding electrons. Okay. Now, if we see all those reactive intermediates, how they are differ in nature with the carbenes. So, reactive intermediates in the chemistry of organic compounds. Okay. So, first we will write the intermediates. Okay. Then number of covalent bonds, okay. Then number of valence electrons. Fine. First consider carbon ion. So, this is having the number of covalent bonds. Okay. So, number of covalent bonds is 3, number of valence electrons definitely 8. Next is the carbonium ion. Okay. So, fine. So, in case of carbonium ion, again number of covalent bonds is 3, but unlike the carbon ion, here the number of valence electrons is 6. Then the free radicals, so like this. So, here also number of covalent bonds are 3, but number of valence electrons is 7. Next, if we consider our interest, that is carbenes, there. So, here number of covalent bonds, unlike other reactive intermediates, here it is only 2, and number of valence electrons also, here it is 6. Okay. So, these are the reactive intermediates in the chemistry of organic compounds, where if we consider those important intermediates, where carbon ion that contains number of covalent bonds 3, number of valence electrons 8, carbonium ions number of covalent bonds are 3, number of valence electrons 6, free radicals again here number of covalent bonds 3, number of valence electrons is 7, and for carbenes number of covalent bonds are 2 and the number of valence electrons are 6. Okay. So, these are the basic differences between all those reactive intermediates I mentioned. Here the important thing that I want to mention again, that here if you see that number of covalent bonds, that is having 2 and number of valence electrons, that is 6. This shows that these types of species are highly electron deficient in nature. So, they will be must be highly reactive. That means, they are very much eager to get another 2 electrons to fill up their octet. So, they will be definitely highly reactive. Okay. Next. Next, we will discuss the classification of these carbenes. Okay. So, carbenes are two types. One is called singlet and another is called triplet. Now, what is their difference? They differ in the electronic structure. Triplet means it should be like this type and singlet means it should be like this. Now, how they behave or what is their geometry, what will be their structures, that we will discuss in detail. Now, question is that these carbenes, when that generates, whether that will be singlet or triplet, that can be again guided by the reaction conditions. Okay. So, now we will see that these carbenes, that is singlet or triplet, how they will behave in the reactions. Definitely they will behave differently, right. So, singlet carbenes will behave differently and triplet carbenes also behave differently. Now, we will learn the structure and geometry of the carbenes. Okay. So, the next topic that will be discussed, that is the structure and geometry of the carbenes. First, we will see this is the carbenes. Now, we will draw its structure and geometry. Okay. 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 So, this is the sp2 hybridized carbon atom, okay, and this is the p orbital, okay, and this is the sp2 orbital, okay. Now, if we take the electrons, now that can stay like this. So, this is called what I previously mentioned, that singlet carbene. Okay. That means, two electrons, that is in this particular sp2 orbitals, and they are paired up. Okay. Next, the same thing, they can stay like this way, So, they can stay alike. Okay. So, this is the again like earlier, this is the p orbital, this is the sp2 orbital, this one also sp2, hybridized carbon atom. Okay. So, now this is the sorry so this is the triplet carbene. Actually, here you can write it like a sigma 2 this, and here it is we can write like a sigma 1 p pi 1, because this is in p orbital, 1 electron and 1 electron is in this non bonding orbital, sp2 orbital. Okay. In general, these are actually bent in structure, bent carbene. Okay. So, their structures are bent. Thank you.